Welcome back to Database Internals Crashcasts. I'm Sheila, and as always, I'm joined by the database wizard himself, Victor. Before we dive in, I just want to remind our amazing listeners that if you're enjoying the show, please rate us on your favorite podcast platform. It really helps us reach more database enthusiasts like you.
Thanks, Sheila, and hello, everyone. We're excited to continue our journey through database architectures. Last time we covered single-tier architecture, and today we're moving on to two-tier architecture. This is part of our database architecture chapter in our Introduction to Databases season.
That's right, Victor. And to kick things off, I have a quiz question for our listeners. Are you ready?
Always ready for a good database quiz? Let's hear it.
All right, here goes. In a two-tier architecture, which tier typically handles data validation? The client tier or the server tier?
Ooh, that's a tricky one. It touches on an important aspect of two-tier architectures. I like how it makes you think about the responsibilities of each tier. What do you think, listeners? Take a moment to consider it, and we'll reveal the answer at the end of the episode.
Great question breakdown, Victor. Now, before we dive deeper, let's make sure our listeners are on the same page. Victor, could you give us a quick definition of what we mean by two-tier architecture in the context of databases?
Certainly, Sheila. A two-tier architecture, also known as client-server architecture, is a software architecture pattern that separates an application into two main components, or tiers, the client tier and the server tier. The client tier is responsible for the user interface and some application logic, while the server tier manages data storage, retrieval, and processing.
That's a great starting point, Victor. So, if I understand correctly, it's like a restaurant where the customers, client tier, interact with the waiters, client-side interface, and the kitchen, server tier, prepares and manages the food, data. Is that a fair analogy?
That's an excellent analogy, Sheila. It really captures the essence of the two-tier architecture. Just like in a restaurant where customers don't directly interact with the kitchen, in a two-tier system, the client doesn't directly access the database. Instead, it communicates with the server, which then handles the data operations.
That makes sense. Now, can you explain a bit more about what each tier does? Let's start with the client tier.
Of course. The client tier, also known as the presentation layer, is responsible for presenting data to the user and capturing user input. It typically includes the graphical user interface, GUI, and some basic application logic. In database terms, this could be a desktop application or a web browser that allows users to view and interact with data.
I see. And what about the server tier? What are its main responsibilities?
The server tier, often called the data tier or database tier, is where the actual database resides. It's responsible for data storage, data retrieval, and ensuring data integrity. This tier handles queries, updates, and all the heavy lifting when it comes to data processing. It also manages things like user authentication, application logic, and business rules.
That's really interesting. So how do these two tiers communicate with each other?
Great question. The communication between the client and server tiers typically happens over a network using standardized protocols. In database systems, this often involves SQL queries sent from the client to the server and result sets returned from the server to the client. The exact mechanism can vary depending on the specific technologies used, but the principle remains the same. The client requests data or actions, and the server responds.
I can see how this might be more efficient than a single-tier architecture. What would you say are the main advantages of a two-tier architecture?
You're right, there are several advantages. First, it allows for better scalability. You can upgrade the server without affecting all the clients or update client software without touching the server. Second, it provides better security, as the database isn't directly accessible from the client. Third, it allows for centralized data management, making backups and updates easier. Lastly, it can improve performance by distributing the processing load between the client and server.
Those sound like significant benefits, but surely there must be some drawbacks as well.
Absolutely, Sheila. No architecture is perfect. One of the main challenges with two-tier architecture is that it can become a bottleneck if there are too many clients connecting to the server simultaneously. Also, if the server goes down, all clients lose access to the data. Additionally, maintaining different versions of client software can be challenging, especially in large organizations.
That makes sense. Can you give us some real-world examples of where two-tier architecture is commonly used?
Certainly. Two-tier architectures are often used in small to medium-sized applications. For example, a small business might use a two-tier system for their point-of-sale application, where the cash registers act as clients and connect to a central server. Another common use is in basic web applications, where web browsers act as the client tier and communicate with a web server that also hosts the database.
Those are great examples, Victor. Now, I'm curious about best practices. What should developers keep in mind when implementing a two-tier architecture?
Great question. Some key best practices include: Point 1. Carefully consider the distribution of processing between client and server to optimize performance. Point 2. Implement robust error handling and recovery mechanisms, especially for network issues. Point 3. Use secure communication protocols to protect data in transit. 4. Plan for scalability from the start, even if you're starting small. 5. Regularly back up the server data to prevent data loss. Remember, the goal is to balance performance, security, and maintainability.
That's really helpful, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. In a two-tier architecture, which tier typically handles data validation, the client tier or the server tier?
Yes, the quiz. Well, the tricky part is that data validation typically happens on both tiers, but for different reasons. The client tier often performs initial data validation for a better user experience and to reduce unnecessary server requests. However, the server tier must always perform thorough data validation to ensure data integrity and security, as client-side validation can be bypassed. So while both tiers play a role, the server tier is ultimately responsible for ensuring data validity.
Excellent explanation, Victor. To summarize today's episode, we've learned that two-tier architecture separates an application into a client tier for user interaction and a server tier for data management. This approach offers benefits like improved scalability, security, and centralized data management, but also comes with challenges like potential bottlenecks and version management issues. It's commonly used in small to medium-sized applications and requires careful consideration of processing distribution, error handling, and security measures.
That's a great summary, Sheila. And remember, listeners, understanding these architectural patterns is crucial for designing efficient and scalable database systems. We hope you found this episode informative and engaging.
Absolutely. And as always, we'd love to hear from you. Visit crashcasts.com to join our Discord community, support us on Patreon, or just to say hi. Your engagement keeps us going. Until next time, keep diving into the fascinating world of databases.